I want to call the March 26, 2015 NDCAP meeting to order. And everybody should be excited because we have a sound system that will hopefully work. And in front of maybe every other person, there's a microphone. And if you turn it on, hopefully it'll work. We also have BCTV with us, and I think they're appreciative of the sound system because they've had problems. What I want to do is just quickly go over the agenda, and there's just one thing that I'm going to add on the approval of the minutes, which hopefully we're going to approve the annual report that everybody, I'm sorry, I sent it out like 3 times to everybody, but I wanted to make sure that everyone saw it. So I start going around the room. We can start with Derek, and we'll all introduce ourselves.
Yes, Derek Jordan, citizen.
Chris Williams, Site VP at Vermont Yankee.
Mike Toomey, representative of Entergy Nuclear, Vermont Yankee.
I'll try the, oh, hey, it's working. Pat Moulton, Secretary of the Agency of Commerce and Community Development.
Martin Langeveld, citizen member.
Kate O'Connor, citizen member.
Chris Camp, Executive Director, Wyndham Regional Commission.
David Mears, Commissioner, Department of Environmental Conservation.
Jim Tonkovich, citizen member.
Bill Irwin, designee for the Agency of Human Services. Chris Recchia, Commissioner of the Public Service Department.
Pete Skibniowski, representing the town of Vernon.
David Andrews, representing the workers, IBEW at Vermont Yankee.
Jim Matto, citizen member.
Thank you. Now what we'd like to do is review and approve the February minutes. I hope everyone's looked them over, and I don't know if anybody has some comments or questions or suggestions. Great. Great. Okay, all in favor of approving the minutes? Anyone opposed? Great. Abstain? Okay, now if we can look at the report to the legislature, and there were 4 or 5 changes on 4 pages that we discussed at the last meeting. They were on page 4, 5, 6, and 9. Do you want me to go over what they are so everybody's on the same page? The one on page 4 starts on line 4, and what we did is took out the wording that says, see the details below in section 4. And then it says, Entergy emphasized that the SAS is a draft document that will continue to be revised throughout the decommissioning process. Obviously, the site assessment study is not something that's going to be revised, so we took out that language. Is everyone good with that? Then on page 5, line 35, we changed the headline or the title. It used to say status of major decommissioning activities at the time of this report. We changed it to read major milestones in activities at the Vermont Yankee site. Does everybody see that? Everybody's okay with that? Page 6, line 3, we added November 25th, 2014, low levels of strontium-90 detected at VY monitoring wells. Is everyone okay with that? Oh, I'm sorry. Okay, I have an old version. Sorry about that, you guys. It says January 29th, 2015. Federal lab confirms findings of low levels of strontium-90 in water samples taken from VY monitoring wells in August 2014. Is everybody okay with that? Okay. Then we went down to line 23. And we just made it so that the report was filed. So it says post-shutdown decommissioning activities report was submitted to the NRC in December. Then on page 9, line 2, we changed it to read, Entergy provided second overview of anticipated emergency plan changes, and the state provided its reactions to that. Is that okay with everybody? Okay. Does somebody want to make a motion to approve the report? Oh, Bill? Yeah, the charter is attached, and we approved the charter at the last meeting. Oh, yeah. Tell me what they are. And oh, yeah. Bill, use our fancy sound system.
I like this job a lot better than the last one.
So it's part D on page 12, line 1, designates city statutory positions in the town may be represented. Word is not that way. So city statutory positions in the town may need to be represented by designee.
Or just take out the 2.
Right, yes. And then there's a G that follows that. In the first bullet, the last line, 26, has the Commissioner of Flood Public Service. It should either be the Commissioner of the Public Service Department or just Public Service. Other than that, I have no other
Someone want to make a motion to approve the annual report? Unless,
I'll make a motion to approve the annual report.
okay, all in favor of approving the annual report? Anyone opposed? Anyone abstaining? We finally have passed our annual report, which we'll submit to the legislature. Yeah, they're just waiting. They're waiting for it. I'm just going to give a quick run through of the things that we talked about at the last meeting that we were going to do before this meeting. One of them is the website, and I want to assure everybody that we're working on it because we come under the Public Service Department. We have to go by the guidelines of the state of Vermont to set up a website. So we're sort of in this bureaucratic machine, I guess we're stuck in, but we're getting closer every single day. So I have this some level of confidence that someday, within the next 60 years, we'll have the Endicap website. And I have to thank Michelle Hughes in Chris Recchia's office because she's been extremely patient, but we're getting there. We also had an issues committee meeting, which David Andrews is going to give an update on, and I did a survey of the dates on where people can meet, and we'll do that at the same time that we do the issues committee. So we actually did what we said we would do. Now I want to pass it over to David, who's going to talk about what the issues committee talked about at our meeting, which I think was a good one.
Thank you. So yes, the Issues Committee met on March 26th at noon in the Wyndham Regional Commission conference room. I was present February 26th, not March 26th, with Chris Campany, Kate O'Connor, Martin Langveld, Jim Mattel, and Dr. Irwin by telecon. We had a roundtable discussion on the topics that we have ahead of us and the direction that we're looking to head. And by consensus, we made some decisions here. The first was clearly that meetings need to be planned ahead of time and not on an ad hoc reactionary basis. They should have a common repeatable structure, and that the structure should include an opportunity to discuss 5 key areas. not in any particular order. The first is an update by Entergy on happenings at the facility. A second is similarly an update by the Vermont officials on what's been going on since the last meeting. A third, plenty of opportunities for public comment on the various topics as they come up. And then for each meeting, we should have a segment which is educational in nature and a segment which is issues-based in nature. And sometimes they'll meld where they'll be one and the same. We also discussed field trips outside of the regular meetings. And we talked about possibly visiting Yankee Row or Maine Yankee or Connecticut Yankee. There seemed to be some favoring of visiting Connecticut Yankee specifically because many of us who were in the issues subcommittee are less familiar with Connecticut Yankee than we are with Maine Yankee and Yankee Row. Also, we felt if it was coordinated properly, we might be able to actually visit Connecticut Yankee and Millstone 1, which are both run by Dominion. Millstone 1 being of interest because it's actually a safe store facility. It's not a fully decommissioned facility. So more to come on that as we develop a plan here. Jay Tarzia of RSCS was already scheduled for March. At this meeting, he serves both, his topic is both educational issues related. The agenda item, which is on our agenda for 7:40 this evening, also serves as both an educational and issues segment. While it's focused on the state agencies, it's open for all board members to weigh in. What we were looking at was there seems to be some confusion as to exactly what each person's roles and responsibilities are on the board, especially with the state agencies. Some of us aren't real clear on how the state agencies interact and what their duties are and what departments are under them. So this was an opportunity to get that out. It's also an invitation for anybody else on the board who wishes to speak as far as what they represent and what their interests are. What's your role? What do you represent? What do you bring to the table? And what are your major concerns at this time? The next meeting after this meeting is scheduled for May, and we decided that the educational segment will be a discussion of unanticipated issues that were encountered during the decommissioning activities at Row, Maine Yankee, and Connecticut Yankee. And the issues segment will be the decommissioning trust fund structure and the uses. What's acceptable versus unacceptable uses, who has the authority to decide in those sort of items. The issues committee needs to meet periodically. We decided we would we'd reconvene after the May meeting, or scheduling wise, it may be just before the May meeting, to continue our efforts going forward in the next couple of meetings based on board input, emergent events, and a prioritization of the existing list of items that we already have that we need to explore. That's a summary of our issues subcommittee meeting.
Does anybody have any comments or questions? Pat?
Just to make sure, David, when you talked about the 5 primary areas, were those essentially, those would be standard agenda items then? Okay.
Talk about how you assign, you went through some topical areas, like for the next meeting, for example. How do you assign owners of, know what they're bringing to the table for a future meeting?
The question as I have it is how to not get somebody surprised to come into a meeting and realize that they're talking about something. It'll clearly be communicated through the chair to make certain that whoever is being asked to speak accepts the invitation and is prepared to speak to the topic at hand. There'll be no surprises.
And would be, once we made a decision like, well, this is what we think Joe Schmo should come in, what we would do is we send it around to everybody and make sure everybody felt comfortable with that, or there wasn't a huge objection. Because we obviously don't want to put anybody on the spot. This is not like our point.
It's not intended in any way to be confrontational towards anybody.
I just wanted to say I think it's a really elegant approach to this and appreciate the thought you put into the others on the committee to put this together.
I guess, I would just say, I think it's good as well, including.
Wow, what is that? The activities are going to require All right, so what I was saying was, David, thank you, appreciate the list, and also clearly some of those items, may require resources, and the department stands again still willing to make sure that the committee has what it needs, the panel has what it needs to do its work, and will support that. I say in these budget times within reason, and I'll work with the chair to go through that, but I feel confident that we'll be able to support you guys in what you need.
Does anyone else have any comments or questions? Oh, Jim?
Very minor correction for the record. Worse, I think we actually met on March 6th.
Okay, now the hopefully not hard part happens, but we need to pick a date for the May meeting and then decide what we want to do. If we want to meet in June, or do we want to skip and meet in July and August, which to me seems like a difficult time, or September. But if we can tackle the May meeting first. I did the survey of what people said they could or could not do, and pretty much what it came down. There's our sound system. What it really pretty much came down to is that what works for most people would be the first and third Mondays of the month, or the first and fourth Thursdays of the month. And we have been meeting on the fourth Thursday of the month, which in May would be the 28th. So I don't know how people feel about that. I know, that's why, it's the Thursday before Memorial Day weekend. Oh, you're right, Memorial Day is the 25th. So I don't, right. Right.
I'm going to shut up now. I have no preference.
Is there a Pat?
I have a general preference for Thursdays, so I guess I'd still stick with the fourth Thursday.
Does that work for most people? So do we want to set the next meeting for May 28th, just the Thursday after Memorial Day? Okay. And what we'll do is we'll find a location and then let everyone know. Now, what is everyone's preference about moving forward? Do we want to have a meeting in June, or do you want to wait until July, August, or September?
We discussed this before. I think that if we, knowing that July and August are probably going to be very difficult months, if we were to wait and not hold a meeting in June, then we're taking quite a long stretch between the meetings. So I'd suggest we hold a meeting in June, understanding that July and August are probably not going to happen, and then move on to September.
Pat? Oh. Go, Mike.
I do think we ought to be trying to get to more of a quarterly setup. That was the legislature said 4 times a year. I think the expectation should be around 4 times a year, although more often than that if needed. My preference would be if we're going to meet in June, that we meet maybe early in June or not have the May meeting. I mean, I don't think we need 2 meetings in May and June. And then we can meet again in September, unless something comes up over the summer. But I'm not sure we have that much more to talk about if we meet in both May and June.
I would second that. I'd love to see us get something more quarterly, or at least every other month. It's feeling to me like we're getting in our stride now. I mean, thanks to yours and Martin's leadership, and that I don't think monthly is really needed. So I would second your point, Mike, and especially if we're going to meet in June, yeah, May 28th, and then turning around and meeting like June 15th or something doesn't seem to make a heck of a lot of sense. And I would absolutely agree, July and August, it's just going to be impossible to get people together. And after this winter, I think we're all going to really be looking for summer and using it hard. So, Jim?
Yeah, I'd like to disagree with that. The legislation says a minimum of 4 times a year, and I don't want to be minimalist about this. And I think the fact that we're just hitting our stride means we should keep striding. And I think there's an awful lot to learn and to deal with, so I would be opposed to that. I mean, to a quarterly.
Breaker? Okay. Yeah, I would concur with, I mean, there's still a lot of catch-up that we have yet to do on just learning about the basic issues around decommissioning, learning from other experiences. During the Issues Committee, I think we talked about that we have a lot of catch-up to do. So I would also encourage us to meet in May and June, and then reconvene in September.
How does everyone else feel about that?
We consider an every other month as opposed to quarterly, I mean, or monthly?
I think in the Issues Committee, that was the thinking, that we ought to try to settle on not quite the quarterly, but every other month. But then we've got the summer problem. So so if we do May and June and skip July and August, that's kind of every other month, except we do the every others first and then the off months. And then we can go, September, skip October, November, skip December, and maybe that'll be the stride going forward.
Does anyone else have a thought on that? Do we want to do it that way? Does everyone feel comfortable doing, I know you folks, but if we did May and June, skip July, August, then did September, November, and January?
I won't be here in June. I've got a trip out of town. I'll be on. So maybe we could not have an Entergy agenda item in June.
Okay.
Maybe that's the compromise.
Mm-hmm. Yeah, we can easily do that, because I think there are lots of other things that are on the sort of the docket to talk about. So we're sort of in agreement that we'll do May and June, but then we'll skip July and August. We'll come back in September. Then at this point, we'll do November, and then January.
Yeah, after the summer break, we could consider, I've been involved in some other organizations and other public hearings. When you get after the summer, you can move the meeting toward earlier in the month so that you avoid the Thanksgiving, et cetera. So that may make more sense.
Yeah. Yeah. And it'll put it, I think, in perfect timing. If we have to do another report to the legislature, we get it done earlier in November, and then January we do it. Okay, so what we'll do, now we'll go back to the June date. Does everybody feel comfortable doing it well, I can actually email everybody if it makes more sense. If we want to do it the 4th Thursday in June. Do we want to just put that in now? Okay. So we'll do May 28th and June 25th. Now we'll move on to the next item, which is the Entergy update on decommissioning activities.
Good evening. My name is Joseph Lynch. I'm the Government Affairs Manager for Entergy Vermont Yankee. I want to provide a brief overview of activities that have occurred since our last meeting in February and bring up a date on some issues that we think are important to the panel and to the public. Since our last update, we continued on with our planned decommissioning activities. Those included working on various plant systems that were formerly in operation. We're now draining those systems and laying them up for long-term dormancy. We're also removing power from certain buildings that are no longer needed, both from a safety perspective and preparing those buildings for a future state, which is known as cold and dark. If those buildings are no longer required, we'll remove any necessary power or safety hazards, and those buildings will be part of normal routine walkdowns, but no longer needed as part of the activities at the site. So that's ongoing. And I also mentioned at the last meeting that we would be doing certain security modifications. We continue on with those modifications. I also mentioned at the last meeting that we had started to do some select building and structure removals. We're continuing with those activities. I have a map that I'll put up on the next slide that kind of shows a little bit of why we chose the various structures and commodities for removal. They are part of that security modification and plan. Removing these buildings provide a better view of the entire site as we ready the facility for dormancy. Since the last meeting, there was a couple of significant milestones and achievements having to do with our post-shutdown decommissioning activities report. As you know, we submitted that report back in December of 2014, and it was in its 90-day review period as allowed by NRC regulations. On February 28th, we provided our answers back to the state agencies that had provided their questions and comments on our draft PSDAR, which we provided as part of the site assessment study in October. We had taken the state comments and incorporated them prior to the submittal of our final PSDAR, but there was a number of other comments that the state had provided, and we sent a letter to the agencies providing our response to their comments. On March 6th, the state agencies collaborated and sent their comprehensive set of comments to the NRC on the PSDAR. And then this past Monday, March 23rd, did end the 90-day comment period allowed by the NRC. And as we understand, the NRC is in the process of reviewing those comments as well as our submittal. This is a map that we had developed at the site that kind of shows all of the structures and buildings on the site. And the map was intended to plan for some near-term activities that would progress through the removal of some of the commodities and structures that I had mentioned earlier. So thus far, we've removed 7 different structures. In one case, it's underground storage tanks. And on this map, this is known as our OSSI pad, which is the on-site storage container. This is a concrete pad that we've rubblized on the site. Sarah's trying to pull up a better map. I guess we could stick with this one right now. So this pad has been removed, and we're in the process of processing that material for disposal. Over in this area, we had what was known as the main Yankee building, a small building that was used for storage. That has been removed. Right next to that, a building called our rotor storage building. That was also removed. Adjacent to our plant support or office building, there was a small fourplex of trailers known as the power uprate building. Those trailers were disassembled and removed, and they actually have been recycled, so they'll be used at another facility. On the south side of the plant, we removed a couple of buildings. One was what is known as the South Warehouse, self-explanatory, a large warehouse for storing materials. That has been taken down. I will mention that the majority of these buildings, with the exception of the Aussie pad, we're leaving the concrete structure in place, and we're just removing the upper structure of the buildings. We also removed a couple of underground storage tanks on this side of the plant. They were used for diesel fuel storage. And then finally, there was an old building affectionately known as the, I think it's the Tub, which is the tan ugly building. I didn't name it, but it was the green ugly building. We painted it tan, and now it's gone, probably for good reason. So that also has been removed from the site. All of these buildings, we, as mentioned at the last meeting, filed all the necessary paperwork and made sure that was passed on to the agencies for their information on the type of work that we're doing. Speaking of our interaction with state agencies, on March 6th, we received a letter from the Agency of Natural Resources requesting some additional information and records from us, really as a follow-up to two things. One, the recent work that we were doing on the site that I just described, and also they had provided certain comments on our site assessment study specific to the non-radiological historical site assessment, which was one of the attachments. So we received that on March 10th, actually, and it was a 14-day reply. The department was gracious enough to hold a meeting last week. We sat down and went over the RFI to get clarification on some of their questions, and we did at the time ask for some additional time because it was about 42 different items that were requested in that RFI. The agency did provide a 3-day extension, and tomorrow we'll be submitting our reply to the ANR on those questions and request for information. One of the things that you may have heard about or read in the newspaper regarding site security has to do with a couple of recent events of trespassers on the Vermont Yankee property. I just wanted to emphasize in this forum, and we're doing some outreach through local media and various signage on the site, but trespassing at our facility, even though we are shut down nuclear power plant, is strictly prohibited, and it's not something that we'll tolerate. We have a rather robust security force 24/7 on the site that will continue going forward, and that security force partners with local law enforcement. So whether it's the state police, the FBI, or the sheriff's office, we are in constant communication with them. And in fact, in response to the two events, we did work collaboratively with local law enforcement to report those events. So we've included a couple of extra signs. If it wasn't obvious before that people shouldn't be trespassing on our property, we'll continue with even more visual barriers to ensure people are very clear that we do not expect trespassers. And the article in today's Brattleboro Reformer was another way of reaching out to people to make sure that everyone knows that we take security very seriously and that there are dire consequences. Our guards are armed, they are trained, they have the same pedigree as people that work for the state police and local law enforcement. These individuals went past our outer perimeter fence and into the area that is outside of the security owner-controlled area. Nonetheless, we take that as serious as that next barrier where more severe actions would be taking place. Just to update you on some things that we're doing to continue our outreach. Of course, we continue to provide updates at this forum. We're doing a number of things, including a meeting in Massachusetts in Greenfield Community College in April, coordinated by Representative Paul Mark. We're looking forward to that opportunity, kind of an information forum. And we continue with tours. We had representatives from Greenfield, including City Councilman Isaac Mass, as well as the fire chief. We had Kate O'Connor on a tour recently. Tomorrow we're hosting some students from UMass Amherst Commonwealth College are coming as part of their class, along with some other individuals. And I'll be reaching out to the NDCAP members for scheduling specific tours for the membership in April. Now that the weather's starting to turn a little bit, it's easier to get folks in and touring the plant. And of course, we keep our new decommissioning website up to date with all information having to do with this meeting, our outreach, and anything that has come up recently having to do with our decommissioning activities. Any questions that I might be able to address? Yes, Pat?
Joe, can you help me understand? I've read with interest the trespassing story, and I'm not quite sure. I understand the front guard house, if you will, is no longer manned, but is there still gating and fencing, and have these people scaled the fence, or are they able to walk right in? Can you help me understand that a little better?
So there's essentially 4 different zones around the most important parts of our plant. So we have an owner-controlled fence, which is the outer fence. We did remove the manning of that gate that was known as Gate 1. So that area essentially has an office building. It has where engineers, my office is, Chris Wamser's office. So you can now drive into that area. You can park in the visitor spot. You can park in one of the 2 parking lots. We only expect people that are either working there or who have authorization to be there to visit during normal business hours. So these individuals entered into that area. Then we have another secure area called the SOCA, or Security Owner-Controlled Area. That has its own fence system that actually has a system that we have to use a badging and a hand geometry to get into. Then we have another area called the Protected Area, and that has yet another set of hand geometry guards. People go through metal detectors, and all of their personal belongings, much like an airport, would have to go through. And then once you're inside the plant, we actually have another area called Vital Areas, where only people with certain authorization are allowed in. So we still have 4 zones. The most outer zone is the one that we just don't have the guards at the gate. With all that being said, we still have guards that are inside the plant that are looking outside. We have cameras, we have night vision. All of that has not changed. But it was unfortunate that 2 people felt it was necessary to trespass. Yes, Commissioner?
Joe, you mentioned in the beginning the OSSI pad and that it was rubblized on site. Could you describe that and explain where the materials are and went?
The materials still remain on site. I believe we're in the final stages of completing turning that pad into a pile of material that can then be transported. And we're going through an evaluation of what options we have for disposing of that material. That material would have been the subject of a plan for radiological examination and characterization. And based on that, we'll make a decision on where the appropriate place is to dispose of it. But for now, it remains on site, and I believe we're going to wait till after quote-unquote mud season to do anything so we can get trucks and transportation vehicles in there. And we'll certainly share with the department the final disposition of that.
Yeah, and for my sister agency's benefit at A&R, do you do non-radiological assessment of those materials as well before you decide where to bring them?
I'd have to check into it. It's a concrete pad, so
Yeah,
I'm
it's
not
probably-
sure there's much in the way of hazards, but I can certainly follow up on that for you.
I think they'd like that.
Absolutely. Yes, Derek?
Yes, Joe, do you, for the buildings and structures that you removed, did any of them contain any radioactive materials?
Not to my knowledge. The pad, the OSSI pad, had containers on it that contained materials in them that had some radiological consequence, but the rest of the buildings, to the best of my knowledge, did not contain significant amount of radioactive materials. Nonetheless, we went through a characterization of all of those buildings to make sure that the materials could be released as normal waste. Yes, Chris?
For the non-radiological materials, are they going like to the, how are you handling the landfill situation? Like, do you already have agreements ahead of time with wherever the stuff is going, or is it not that large a quantity that you don't have to have prior arrangements?
All of these were being done by local resources, local contractors that have the waste streams already figured out. In some cases, the buildings have been recycled. So in other words, in the case of the trailers, they'll be used someplace else. I believe at least one of the other structures will be reassembled somewhere else, so they were careful to take it down, and it actually became something that we could reuse somewhere else, off the site. And then the balance of it, most cases it was steel buildings and steel material would have been sent to the proper type of landfill or recycling facility. Any other questions?
Is there, you implied there was, is there a clearer map that we could get?
Yeah, the map that I had put up, if you want to put that. This is actually the clearer version of that map. You'll note that I had put draft on it. So we're trying to create something that is easy to understand. What in essence we've created is a color-coded map. Each color denotes when we believe is the right time to remove those buildings. So the ones in orange, for example, and hashed are the ones that we plan on doing this year. The other color coding, and I don't have the legend there, would be something that would potentially be done in the near term over the next couple of years, and then the majority of the other colors and structures would be part of the layup into dormancy and then be done as part of license termination.
Would it be possible to email us a copy of that?
I'm working with Ms. O'Connor to get that out to everybody.
Thanks.
Wasn't this, the general layout, wasn't that in our site assessment study, do you recall?
There is a map. This provides a little bit more detail, but this essentially is what is in the early part of the site assessment study, but provides a little bit more detail on kind of the time frames as we see them. That's correct, Chris. Okay. Thanks.
We're hoping this works. Next up, we're going to have a update from the state, but I'm wondering if you folks want to wait and do it all at the same time when you give us, or how would you like to proceed?
If it's useful, I thought maybe Tony could take just a couple of minutes to talk about what he has observed being on the site, and then we'll do the more generic agency stuff in the later part of the agenda. Is that okay?
No, that's perfect.
Okay.
And actually, Tony, when you tell us what you observed, do you want us to give us like a short description of what you do? Because we know you do the sound system, but we know you do it.
Oh, don't blame him on
we know you do a lot more than the sound system.
You can't blame me for this one.
Yeah.
So I will object to be blamed for this particular sound system this evening. But good evening, everyone. I am the state nuclear engineer for the state of Vermont. My name is Tony Lashinsky, and I've been in this job for, I have reading glasses, and sometimes it makes more sense to take them off. But I've been in this job for about 9 or 10 months now. And Primarily, what my job is to provide information, and that is not only to the Public Service Department, which is who I work for, but when necessary, the Public Service Board. And I provide quite a bit of support for the Citizens Advisory Panel itself. And that means providing information to the Citizens Advisory Panel, as well as making certain that the state agencies that need information, be it from Entergy or from the Nuclear Regulatory Commission, that they have that information available. And when necessary, I do help to interpret what that information actually means. So that's a very short explanation of what my job is overall. Now, most of the time, rather than being up in Montpelier, I'm actually down on the Vermont Yankee site. And as Joe described, the protected area, my office right now is actually within the protected area. So every morning as I go into Vermont Yankee, I go through all of the security steps that Joe outlined. They are quite robust and in compliance with NRC requirements as I know them. So to give you an idea of what has been going on from a state perspective, much of what Joe has described is spot on what's going on with the plant. There are a number of what are now deemed non-essential structures have been removed. The concrete pads that were underneath those structures, Joe described the tub and the main Yankee building in particular. Yes, those concrete pads are in place. I can attest to that. I walked past them. And so as those structures started coming down, I was certainly passing that on to the Public Service Department and to Agency of Natural Resources, being that there was a possibility of some items to be cleaned up that ANR would be interested in. I can say that as those structures came down, that I did see indications that there was separation of materials, some items for scrap and some items that were definitely for just going to an appropriate landfill. So that has indeed been done. So besides that, and I was expecting to speak this evening, just not at this point and quite on this subject, so I winged something very quickly here. But just to give an idea of what else has been going on, in addition to what Joe outlined, with respect to the described Aussie pads, just to clarify what that is, there was previously a low-level waste storage facility on site at Vermont Yankee. And the decision was made for security purposes to bring that down. This improves the sight lines, which makes security, it improves the security is what I have been told, and from what I can see, I would agree with that. But some radiological evaluation of that now debris material has been done. My understanding, and this is through discussing with the issue with the NRC, is that there is more to come on that. And so that information will be made available as it is done. As far as the site, the removal of that material, that is on hold right now for a number of reasons besides what Joe described. There is an NRC inspection that needs to be done with that. And the person who will be doing that inspection is unavailable at this point. He is busily working on another project with the Beaver Valley Power Station out in western Pennsylvania. So, so that's a little more on that. Let's see, I'm just running through, just trying to see what else I have here. Besides those activities, there were a number of review items, namely submittals that Entergy made to the NRC that came up. There were public comment periods open on a significant technical specification change now that Vermont Yankee has shut down. So one of my activities was to review that to see if I had any technical questions on it. The questions were very minimal, and actually when I went through the initial submittal, the only questions I had were actually the same questions that the NRC had and had requested additional information. So in the supplemental submittals, my questions were answered. So that's actually very good to learn. Also related to that, and this is not really me, but just what the Public Service Department has been doing, there are a number of questions or a number of issues where there have been filings made, and I know Commissioner Recchia will talk more about that later. Besides that, two other significant activities, and these are the last two. The NRC did make its initial inspection of the spent fuel pool cooling system. I don't remember what date that was, but I do have the ability and the consent from the NRC to follow along in those inspections. So as the resident inspector from the NRC went through that inspection, I was there with her, just following what she was doing and seeing firsthand what the condition of the equipment was. And there was one very minor finding, but it's more a paperwork issue than anything else, and is not worth mentioning regarding any kind of technical issue. The other item, on March 11th, there was a drill conducted, an emergency drill. This is in preparation for a drill that will be graded by FEMA on, I believe, May 13th is the date. But this was a preparatory drill that had both Entergy and state participation. There was also participation from representatives from New Hampshire and Massachusetts as well. And that's pretty much what I've been doing, and a good idea of what the state has been doing in the past, since the last time we met. Any questions, anyone? Okay, thank you.
Thank you, Tony. The state is going to come back in a little bit and do a bigger presentation. But right now we're going to have a presentation by Jay Tarzia, who's going to talk to us about dry cask storage. Senator Kelly was going to introduce Jay, but her session ran late, and I think she's trying to get here. But in her absence, we have Diane Becker, who's the Chief of Technology Hazards from New Hampshire, who's going to introduce Jay.
Good evening. I am very pleased to provide an introduction of Jay Tarzia. Jay has actually worked with the state of New Hampshire for quite a while. He is the chairman of the New Hampshire State Radiation Advisory Committee, and also obviously the principal of his company, Radiation Safety and Control Services. As a member of New Hampshire Homeland Security and Emergency Management, our agency was empowered by the governor for the state of New Hampshire to have a decommissioning committee when we first learned that Vermont Yankee was going to be decommissioned. And this was made up of some representatives from state agencies and some of the local agencies and individuals who felt that decommissioning may have an impact on, obviously, the southwest portion of New Hampshire. We were told about Jay. We asked Jay to come, and we continue to rely upon him as one of our subject matter experts. He also did a presentation for a public forum that was held a few months ago out in Hinsdale and was very well attended, and I just can't say enough about the expertise and technical knowledge that Jay has provided to us in the state of New Hampshire. So I am very, very pleased to be able to present him to the NDCAB as a presenter.
Thank you very much, Diane. I need to take you home so you can give that speech to my wife. Everybody hear me? Okay. Again, my name is Jay Tarzia. I'm very pleased to be here tonight. I want to thank Diane and our honorable senator from New Hampshire, Molly Kelly, for asking me to be here to give this presentation. I was asked in October to do a general overview of dry cask storage at the Hinsdale meeting, and after that meeting, there was some interest from a few folks to present a similar presentation at this meeting. So I appreciate the fact that you folks are allowing me to do that, and I'm grateful to be here, and I wish you all well. My background is in radiation safety. I graduated high school in 1980, and I wanted to be an engineer, and I always liked science. And going through looking at different colleges, I ran across a very world-renowned health physicist. His name was Dr. Ken Scrabel, who's become my mentor in life and in education. And I fell in love with the study of radiation safety, mainly because it's all faceted when it comes to science. It includes biology, chemistry, physics, and it's a public servant type of science, because somebody that practices health physics is practicing safety, radiation safety. So really my whole career has been dedicated to that. I'm a certified health physicist, and there's an organization in the United States called the American Board of Health Physics that certifies folks in the radiation safety field. Dr. Irwin is also a certified health physicist, and as a certified health physicist, I won't equate it quite like the bar exam for lawyers, but it's a national certification in the field of radiation safety. For the past 25 years, I've been involved in my company, Radiation Safety and Control Services, and what we do is we provide radiation safety consulting, services, and so on for all different aspects of companies that use radiation, radioactive materials. So we've seen a variety of different issues involving radioactive material and licensing and radiation safety, and we've worked with different companies that manufacture dry cask fuel canister designs. We've worked in the transfer of the fuel area, as well as in many other industries involving radioactive material, including hospitals, research companies, and so on. What I'm going to present to you tonight is a short presentation on the general characteristics of dry fuel storage, and really what the purpose is. Hi, Molly. Let's rewind the clock back to the late 60s, early 70s, when nuclear power was first starting to become popular in the world. And the United States had a little bit of a lead on building nuclear power plants. It was never envisioned that nuclear power stations would have dry fuel storage facilities, because if it was, it probably would have been built into the original design of the facilities. Back when plants were being built in that era, it was envisioned that fuel would sit in a temporary storage location, primarily the spent fuel pool, and then after a few years would be shipped off for reprocessing. The unused uranium in the fuel would be reconditioned to be made into new fuel, and the waste portion of that would be condensed and put into waste storage. Many, many countries all over the world are still following that same fuel cycle program. France is a leader. The Asian countries are becoming leaders in that. Unfortunately, in the 1970s, the United States decided to stop fuel reprocessing. And because of that, there was no place to send fuel. So the fuel kept being stored in spent fuel pools at nuclear power facilities until we had to find a solution for that. You all know the story of Yucca Mountain and long-term storage in the United States, and there hasn't been a solution developed as a national storage repository for fuel. So because of that, nuclear power facilities had to design, along with suppliers, an interim longer-term storage solution. And that was the genesis of dry fuel storage. You can't keep fuel piling up in a wet fuel storage facility because they're not big enough to store all the fuel for operating a plant for the 40-year design life. So we needed a solution. So in the 1980s, dry cask storage was invented. Okay? We have a lot of acronyms in the radiation world, as we do in a lot of different industries. My wife's in the medical industry, and I think they have more acronyms than we do. But we have one acronym called an ISTC, which has been developed over the last 30 years or so, which stands for Independent Spent Fuel Storage Facility. And really what that is a long fancy term for dry cask storage of nuclear fuel. So what is a dry cask storage system? Well, it's really just what it says. It's a system that's designed to take spent nuclear fuel, fuel that's no longer useful from an operating reactor, take it out of a wet storage environment like a fuel pool, and put it into a very secure, dry canister for long-term storage. Now, the general design characteristics for all of these systems are very robust. There are many different variations of dry cask storage systems out there, but they all have very similar characteristics. Very thick steel canister, 3 to 4 inches thick, that's totally encapsulated, solid, welded system that sits in a shielded concrete or steel outer container where the heat from the residual radioactive decay is vented through vents at the top of the outer canister. Now what I mean by that is the inner sealed canister gets warm, slightly warm due to the radioactive decay, and that heat dissipates from air circulating around that dry sealed can. Okay, and it's much less heat than your home furnace will produce when it's operating at full power. These canisters are designed to resist many different, as you can imagine, natural disasters, earthquakes, floods, tornadoes, projectiles, and temperature extremes. Some of the design characteristics or considerations are tip-over, impact stresses, thermal stress, criticality analysis, and what that means is designing these so that there's absolutely no way that the fuel could become critical like it does in the core of a nuclear reactor. They're designed for security purposes, and then obviously, ultimately, radiation shielding so that people that come near these facilities are not exposed to an overdue amount of radiation. When they first developed the design criteria for these types of systems, the government was actively involved, and we, United States government, did a series of very, very conservative tests on the canisters that were supposed to be used for the early designs back in the 80s. I'm sure any of you that have visited one of the energy centers at some of the facilities, or even looked at some of the NOVA and, History Channel over the years related to nuclear power or nuclear waste, have seen some of the locomotives running into brick walls and these canisters being dropped off of helicopters onto concrete pads and things like that. And they're all online. You can go online and look at some of these earlier tests that were done to develop the design characteristics. They're also designed to prevent any damage from fighter jets and commercial airline planes crashing into these facilities and so forth. Currently, we have a large amount of dry cask storage facilities licensed in the United States. We have 2 different types of licenses that the NRC issues for dry cask storage systems. You can either own one under what they call a general license, which is a license that the NRC issues to the manufacturer that can be passed along to the owner of one of these systems, owner being the utility that has a nuclear power plant, or the nuclear power plant company can apply for a specific license to the NRC to own one of these systems. Currently in the United States, we have 59 systems that are built and licensed under general licenses. We have 15 systems on sites that have specific licenses, and we have 6 sites currently pursuing the construction of dry cask storage facilities under a general license. The initial license period for all dry cask storage systems in the United States is 20 years, with the provision that they can be extended for an additional 40 years, okay? Currently, nuclear power plants' initial license is 40 years. Whether they stay operating for 40 years depends on certain conditions, as you all know. And most nuclear power plants that have exceeded their 40 or are about to exceed their 40-year license can apply for an additional 20-year extension. So the licensing process allows for safe storage of fuel up to 100 years from the time the plant was built and initially licensed, 120 years, if the plant gets all of the extension licenses and the fuel itself sits in the dry cask storage for the maximum amount of time that it could. Now, as you can imagine, the NRC has a number of different required reviews and inspections, and they're currently developing an extended storage program to look at long-term storage up to 300 years. That's in somewhat of an infancy stage, but for long-term ultimate storage of spent fuel, the country and the Nuclear Regulatory Commission in general, I mean in particular, is looking at developing systems or certifying systems that can last up to 300 years. Now, in addition to the general design criteria of these types of systems, which was set forth in the original criteria for manufacturing, the NRC also requires certain tests on each individual system before it can be licensed. These tests include a 30-foot free fall onto an unyielding surface, a 40-inch fall onto a 6-inch diameter steel rod. You can see one of those tests being conducted here in this picture. A submerge test or water test where the capsule is submerged to 3 feet of water for 8 hours, and then also a separate test where the containers are submerged in 50 feet of water for up to 8 hours. There are many different manufacturers out there developing dry cask storage systems. In the United States, we have 4 companies that are currently licensed to distribute these types of systems. BNG Fuel Solutions, Transnuclear, Holtec, and NAC International. And you can see each one of them have more than one design that they're licensed to build. And the nuclear power company can choose any one of these licensed types of systems depending on the type of fuel that they have and the situation that they have at the site in terms of space and security and so forth. They each have a little bit of a different design, but they're all designed with the same safety design criteria. The NRC issues what they call a certificate of compliance for every system that's installed, which means that it's like a permit in a sense that guarantees that it's gone through all of its proper testing and meets all of the design characteristics for the type of fuel and so forth that the plant will be loading into those casks. Some of these designs have multiple models as well. So, for instance, Transnuclear has 5 COCs, or certificates of compliance, but they have, I believe, 15 different types of model canisters. And that's because different models of nuclear power plants have different size fuel, have different types of fuel, and they have to have a slightly different internal design to safely hold the fuel elements. So the types of configurations that a plant can consider installing range from storage cylinders that are, have their internal cylinder installed upright on a very thick concrete pad. And this is the most common type of dry cast storage system that we have in the United States. You can also have a horizontal design, as you see here, where they build this big shielded, I called it a building, but it's really a structure, I guess, a shield structure, and the inner can gets slid into slots within the structure that have very big shielded doors that go on the front of it when the canister is installed. And then there's another type of system that's an upright system, but the storage facility is built underground, and you can see that configuration here. So just a little history of dry cast storage. The first dry cast storage system, as I mentioned, went in, they really designed these in the early 80s, and the first one was installed at the Surrey Nuclear Power Plant in Virginia in 1986. I mentioned there were 59 systems that were generally licensed, and I believe 15 that were specifically licensed to date, and there has been no recorded known or suspected attempts at sabotage, no known releases of radiation, and tests have confirmed that all of the systems that were installed to date are providing safe and secure storage of fuel. Now, you know, I realize that there's a lot of concern about the safety of fuel, and I think it's imperative that we have a program to monitor these systems, but there has been no known or documented releases of radiation from any of the testing that's been done on even the earlier canisters that were installed back in the 80s. So here is a diagram as of March 17th this year of the dry cast storage in the United States. The green dots are the reactor sites that are licensed under the general license criteria. The blue, the purple sites are let me see here, I want to make sure I get this right. The purple sites are the specific licensed sites, and the light blue ones are the ones that are pursuing the construction of an ISPC as we speak. The little orange ones here are the sites that said, we're thinking about it, but we haven't actually applied for an application yet. So as a nuclear power facility that's thinking about installing a dry cast system, some of the considerations that they must think about are, you know, what type of spent fuel pool do they have in loading configuration, because in order to load the fuel into the canister, you have to do it underwater. And depending on the space in the fuel pool and the design of the fuel pool, it might dictate the type of canister or the type of system that you choose. You have to consider how you're going to handle and move the fuel into the canisters from the fuel pool. How are you going to ultimately move the cask from the loading site to either the pad or the structure that will be the ultimate shield for the canisters. And then finally, you have to look at the design and the security situation at the site and see what's the best type of system for the site, depending on layout, footprint, and all that stuff. So the sites typically do a very lengthy evaluation to determine, you know, what systems would work the best for their facility, and then they can choose from one of the many licensed types of systems to install on the site. So the pool to pad process, and this is something that a lot of people don't understand. One of the advantages of the dry cast storage system over fuel in a fuel pool is It's a very passive system, right? When you have anything that's stored in water for cooling, then the water has to be processed and cooled, and you have to have active systems to maintain the cooling properly and all that. That can be done safely if, with the right types of systems and so forth, but it's an active system that needs to be maintained and monitored. When you place the fuel into a dry cask system, this inner, very thick stainless steel can is ultimately drained, vacuum dried, and what I mean by that, they pull a very strong vacuum of helium and inert gas on the canister and dry out all the moisture within the canister, and then they fill it up with helium under a slight vacuum, and they have an automatic welding machine that welds it shut using robotics. You can see the welding machine welding the top of one of the canisters right here. So when the fuel is ultimately sealed in that canister, there is no liquid in the canister. There's nothing to leak in terms of liquid. So it's a design that prevents the use of water. Once that's welded shut, then this canister, which is all being loaded in a very safe, shielded environment, is placed into the outer cask or structure for shielding, and then it's finally moved to the final resting place, which would be the pad or the underground storage facility or the horizontal structure. These are some pictures of underwater loading of some of the, and you can see how thick these canisters are. These fuel elements are generally around 6 inches square, roughly, 5 to 6 inches, and you can see them in reference to the thickness of the canister here. So they're very, very robust cans. They're not tuna fish cans. They're very thick stainless steel containers. Here you can see where the cover is being placed on one of the cans. This device here is a shield that goes around the canister. A transfer, they call it a transfer cask, because in order to lift this thing outside and put it into one of the final shields, you need to protect people from radiation. So this lifting device and outer casing here is designed to shield the radiation from the inner can. Here you see it being lifted out of a spent fuel building onto either a truck or a transporter to be brought to the spent fuel pool, the ISPC storage location. And these are 3 typical installations. Here you see, again, an underground storage facility where the can will be lowered from this outer transport shield into one of the holes in the ground. A very thick shielded cover will be put on, and it will be there for storage until the government takes custody of it. Here is another picture of the horizontal design, and you can see where this holds several horizontal casks, and these very thick shield doors are in place now because the canisters are there. And here is a vertical pad system, like we talked about earlier, where the shields are located on a very thick concrete pad. Now let's talk a little bit about what happens to the fuel over time. This is another thing that a lot of people don't realize. This y-axis represents the amount of radioactivity in the fuel when it comes out of the reactor initially. Okay, and this curve represents the decay of the fuel after the fuel is in storage. Now, these numbers are relative, so this graph is in gigabecquerels, which is a measure of the international unit for radioactivity is a becquerel. This is gigabecquerels. This is 10 to the 7th gigabecquerels. After about 100 years, because each one of these is 10 years, right, and it's a log scale, so that's 10 to the 6, 10 to the 5. After about 100 years, the amount of radioactivity in the fuel is about 1% of what it was when it came out of the reactor. Okay? So the fuel loses its radioactivity over time. Now I know 1,000 years is a long time, but after about 1,000 years, okay, excuse me, 10,000 years, okay, or a little less than 10,000, about 5,000 years, the fuel is back to where the original uranium was. Now, 4,000 years is a long, long time. I'm not trying to justify or stand on any side of this, but I think an important thing to understand is for nuclear fuel, it will go away someday. The radioactivity will go away. We need to manage it for a long time, right? So one of the things that we do, with these designs is we look to make sure that the amount of heat and the amount of radiation that will be emitted over a period of design will be adequate and conservative to handle any type of safety issue over that period of time. Once you get down to about 1% of the radioactivity in the fuel, the decay heat is very, very low. Now there's still radioactivity in the fuel, but the safety of the systems that are required in 100 years are going to be much less than the safety of the systems that are required today. So if we design systems that are extremely robust, that can handle fuel today, what we're hoping is, and what we're designing into the system is that the fuel will be maintained for many, many more years after that. So for dry cask storage, a lot of questions come up about the security of the systems. We talked about the fact that they're passive, much more passive than spent fuel pools. But the facility that the dry cask storage systems are installed in, the ISTCs themselves, are subject to very similar security requirements as operating nuclear plants. So security doesn't go away when the plant goes away if there's a dry cask storage system on site. There's a very secure system in place, very similar to what was in place when the fuel was, when the plant was operating, except it encompasses a smaller footprint because the ISTC generally takes up a lot less space than the nuclear power facility did originally. The NRC continues to evaluate the security of nuclear facilities, including ISTCs, in light of current security threats, and that's evident by all the changes that have gone on since 9/11. They're constantly looking at security requirements, not just for nuclear power, but even for hospitals and other industries that use radioactive material because of the current security threats today. As a matter of fact, I don't know if any of you have heard of NRC's new rules that were enacted within the last few years called Part 37, but they were put in place after 9/11 specifically for high-level medical gauge sources and other industrial sources of radioactive material that did not have the security that nuclear power facilities have, and now they have much more in-depth security requirements than they had before because of current security threats. There's a number of hostile action studies that have been done in the last several years on fuel canisters. Sandia Labs subjected a steel and concrete cask to a device 30 times more powerful than an anti-tank weapon, and they found that it maintained its integrity. Another study involved, a commercial jet at 350 miles per hour impacting a dry cask container, and that resulted in no release. And they did a number of other analyses. One included a hypothetical F-16 strike on a cask, and again, they did not identify a breach of the canisters. So these studies continue to happen to identify safety concerns involving these types of systems. Unfortunately, we had a nuclear disaster in Japan, as you all know about, back a few years ago. And what happened here was truly not a good situation. But it wound up being a realistic test on dry cask storage systems, because Fukushima had a very active dry cask storage system on the site for their fuel. And even with the massive damage that occurred at this site, they had 408 fuel assemblies in dry cask storage within their structure. They were thrown around. They were, the storage structure itself was highly damaged, but the casks themselves were not compromised even after a 9.0 earthquake and the massive tsunami. The storage building did undergo some significant damage, as you can see here. Here's one of the casks itself that was thrown around after the earthquake, but the cask itself that contained the fuel did its job. So we were all glad to hear about that. So that's really it. That's kind of the high-level overview of the systems that are out there today. I'll be more than glad to entertain any questions if anybody has any.
Thank you, Jay. Appreciate that. Thanks for your presentation. Quick question on the casks and the different models. Is there anything you can tell us about what to look for in the different models, or what the advantages or disadvantages are? Obviously, they all have to go through pretty substantial testing, and they meet that. But I'd be interested in that. And then, secondly, looking at the chart, it is between 1,000 and 10,000 years before we're down below ore grade radiological material. How often do you anticipate, because I know it hasn't been done yet, these having to be changed out? And is that the same process as the original, putting them in the original casks? Or is it because the radiation has decayed to 1% of it, do you think a different system at that point would be warranted? So any thoughts you have on those two things would be appreciated.
Let me answer the first question. I mentioned there are several different designs that were licensed for these types of systems. Every type of reactor has different types of fuel, all right? Some designs cannot be used for certain types of fuel because it might be specifically designed for a pressurized water reactor Westinghouse fuel. Some might be designed for a combustion engineering fuel size and type. Some might be designed for a General Electric boiling water reactor. So first thing you need to look at is what types of systems are designed for the types of fuel that you have, all right? All canisters are not designed to take all types of fuel, okay? There are canisters out there designed for all fuel, but not all systems can take all types of fuel. The next thing you need to look at is how old is your fuel, okay? If you're building a system to store fuel that's more than 5 years old, you have a larger set of systems you can choose from than if you want to put fuel in there that's, say, 3 years old. Because between 1 and 5 years, the decay heat in the fuel is substantial, okay? After about 5 years, the decay heat of the fuel, it decays quite a bit in the first 5 years. So the residual heat is much, much less. So there are more systems that are designed for fuel where the heat is at a lower level. There are some, what they call megastore systems that are out there now that are designed for plants that want to take fresher fuel and put it in the systems. They have larger, more heat reduction capacity and things like that. So you'd look at that criteria, okay? And then some of it's preference, okay? Some of it is how do you want the design to look? I'll give you a good example. Out in California at Humboldt Bay, their nuclear plant is built right on the ocean, okay? Where there's people, surfers and stuff going by, and they're decommissioning Humboldt Bay. They chose, whoops, what did I do? They chose the underground system just to be a little aesthetically pleasing so that you didn't have the casts sitting on the beach, okay? And that was one of the criteria that they used for selecting that type of system. If, you might have a certain footprint that you have to work with. Certain systems have a smaller or larger footprint that you need for the same amount of fuel canisters or elements. Where this system here, they're closely packed together in a building type structure. There's space between this system here. So it all depends on what you have to work with, etc. In the type of fuel and a number of other variables as to what you'll install. Did that answer that question?
That answers it.
Okay. I'm sorry. And the next one was on.
Next one was
On just the life of each of these canisters and what happens, to get you through the 1,000 years or 10,000 years, depending on where you are.
I'm not sure everybody knows that answer to that question, but I will say that as I mentioned earlier, we know that after 100 years, okay, the requirements for storing the fuel, because the heat load is very, very low at that point, is much less than the canister we design today, right? So I don't know if anybody has the capability of doing a study to prove without a shadow of a doubt that these canisters will last for 300 or 500 years. But they're running computer models now to try to postulate that. And there's things we need to consider in those long-term storage plans. Ultimately, I think the hope is that we're going to find a long-term storage solution like France has and some of the other countries, where we'll either vitrify the fuel and glass encapsulate it, which has been really shown to be a very longer-term solution, okay? And then find a repository that we can store it in and feel comfortable with ongoing monitoring. But, we don't have those answers yet. Somebody asked me recently whether I was a proponent of nuclear power or an opponent of nuclear power. Well, as a radiation safety professional, knowing what I know about nuclear power, I will say I believe it should be part of our energy mix. Should it be all of our energy? Absolutely not. And should it be our long-term solution for energy? Absolutely not. But this is my feeling on something like nuclear power. It's an interim solution to electrical production. We can't live anymore without electricity. We'd be going back to the dark ages. We've shown that electricity lengthens our lives. It gives us a lifestyle that we have become accustomed to. It's a really, really remarkable thing. We know we can't go on producing it with oil because we're going to run out of that, and we should be saving our oil for portable uses while we have it. We shouldn't be using natural gas for it because we should be using that to heat our homes while we have that. Coal is not a good solution because it's dirty and it pumps a lot of dioxins and other things in the air. And nuclear is not a perfect solution because it has nuclear waste. We have to deal with all these issues, although being clean, when it's operating, we've got a lot of these long-lasting solutions. However, but what I do believe is that the ultimate source of electricity will eventually come from the atom. Okay? It's the only place it can come from. It's going to come from fusion. All right? There's companies right now that are developing fusion of boron atoms that lead to have a real promise in producing net positive electricity within the next 30 to 50 years. And if they can conquer the challenges of that, okay, we will have almost an unlimited supply of electrical power that produces no nuclear waste. Okay? However, in order to get there, you need smart people to be able to look into these things. The nuclear power industry fosters nuclear engineers and atomic scientists and all this stuff that will ultimately lead into the next era of power production. You know, you look at the development of cars in the early, 1900s and all in the nasty stuff we put into the air and the water. If we had not done that, we would never be where we are today with clean cars, clean factories and scrubbers and things like that. You wish you could start from the beginning with the perfect solution, but we can never do that. It's a learning curve. So that's my feeling on nuclear power, is it's a stepping stone to something that's hopefully going to be brighter, better, and a much more viable solution to produce electricity.
I think I remember from the Hinsdale presentation, Chris Campany, when Regional Commission. Are you overseeing or managing the Roe and Maine Yankee sites, or do I remember that?
Are we overseeing?
Well, are you managing?
We're doing the
those sites?
radiation safety aspects of the dry cast storages, yes.
Okay.
At the Connecticut Yankee, the Yankee Row, and the Maine Yankee dry cast storage systems. And what we do is we'll come in on a periodic basis and do the radiation surveys. We go in and do the audits, the annual radiation safety audits, and things like that for these types of systems.
Do you know, as I recall, I mean, those above-ground systems are similar to what Yankee has and is proposed, right?
Yes, as a matter of fact, those systems are the NAC systems. They look just like that.
Do you know what kind of security buffer NRC, Nuclear Regulatory Commission, is requiring around those?
Security, you mean buffer zone?
Yeah, yeah.
I don't know. I think the fence line depends on a number of different factors. I don't, off the top of my head, remember what the actual distance is that they're using. It varies not only on the security requirements, but also on other things like radiation exposure and things like that from the site. But maybe Joe could, I don't know what you have at, what the buffer zone is at Vermont Yankee, I'm not sure. But it's not a consistent value, I'll tell you that. Each site's different in terms of the fence line and so forth, depending on the criteria that they have.
Okay.
Pat Moulton, Agency of Commerce. And this question will show that I am in desperate need of a site tour. But what kind of dry casts are we using in Vernon?
I believe you're using the Holtec High Storm 100 system. I can default to, I got a picture. A picture here I can show you on one of the slides. I believe that's of the Holtec system. I think it's right here. That's the Holtec High Storm. It's not Vermont Yankees, but that's the similar cast design. It's a vertical cast design, as you can see here. And here's one of the casts, the Holtec cast being transported to one of the site's pads right now. And that system was developed and licensed in, I believe, June of 2000. So it's been around for a while.
Did I understand correctly when you said that in 100 years the radioactivity would be about 1%?
It's about 1% of the...
Can you go to the graph? Because when I look at 100 years, which I think is 10 to the 2, and come up, it looks more like 10% to me.
Yeah, let's look at it.
And it's probably, it says a lot about you can tell which college courses I cut, but
Well,
that's what I think I see.
This is 100 years, okay? And this is, well, maybe a little less than 100, a factor of 100. It starts here, but...
You're not looking at the total.
Yeah, you're not looking at the total, unfortunately, right, because it goes up, right. This is 10 years, and that's 100 years. So, but it levels, it's pretty much the first 10 years it levels out. So it might be a little less than 100 years, but it's actually, probably, as this goes up, it's probably a little more than 100 years, right? So it's probably up to about here. So it's about 100 years.
Means total radioactivity, right?
Total radioactivity, right.
So it's more like 10%, 100 years.
No, this is 100 years. So if back in year 0, it's up here somewhere, and this is 10, 100, right? About 100 years.
You should put lines on this graph.
Yeah, this is from I could have drawn my own graph, but then you would have said, where'd Jay get that information? So I pulled the graph off of the Nuclear Energy Agency, which is the international organization that looks at these things.
So I think you might have confused a couple people here. This graph is total radioactivity. This is in gigabecquerels decaying over time.
That's correct.
And while this was up, you made a reference to the decay heat and the fact that the vast majority of the decay heat is gone in the first couple of years. Can you speak to that and differentiate
Yes,
the two?
Right. Well, there's different types of radiations that come off of spent fuel, okay? There's gamma rays, beta particles, alpha particles, okay, and some neutrons. The fuel, the amount of radioactivity that decays in the first 5 years emits a lot of the types of radiations that lead to a large amount of heat, okay? And they decay very, very rapidly over the first few years because they have very short half-lives. After 5 years or so, the decay heats drop down quite a bit, and it obviously continues to drop down. This is not a graph of decay heat. This is a graph of radioactive decay. I should have actually thrown a picture of the decay heat curve up there. That would have shown you how that decays as well. But a lot of the what we call short-lived radioisotopes with very short half-lives decay very quickly over the first several years, and that takes a lot of the heat away, okay? The actual physical warmth of the canister, so that you can store fuel in different types of canisters after 5 years than you can before 5 years.
As a quick follow-up to that, what we're also saying is within those first couple of years, as the short-lived fission products decay off and the decay heat decays off, so very rapidly also drops off the dose.
That's true. And that's a very good point, David, because a lot of the short-lived radionuclides, the ones with the half-lives that are very short, they emit gamma rays. Right? The gamma rays are the energies that can actually penetrate through concrete to some extent. They don't all get through there, but you get a little bit of radiation dose outside the concrete shield, very, very, very low amounts. But after the first 5 to 10 years, a lot of that goes away because the gamma rays from the short-lived radionuclides are decaying away. So the longer-lived radionuclides tend to emit alpha particles, which do not produce, number one, as much heat, but also external radiation from gamma rays. Dr. Irwin?
Thanks for the presentation. Went back to this, I guess I'll address something. 1,000 gigabecquerels is closer to 2,000 gigabecquerels of the activity of the original ore. That's a lot of radioactivity. I think it's important to note that that horizontal line going across there is not some sort of safety level of radioactive material. So that's not my main point, though. My question is, relative to the 74 systems that are in use around the country, how many of them are the bunker type or the reinforced concrete storage? And how many are the open air storage that would appear to be a whole lot less expensive?
I'm not sure the open air storage in all cases is less expensive, because I've been involved with the construction of some of these from a safety perspective and seen some of the estimates. It really depends on the type of canister, the type of fuel, and so forth. But they are more prevalent. So maybe in general that might be a factor, Bill. But I don't have data to prove that in all cases that's the case. But I don't have an exact number, but I can tell you I believe there's 2 or 3 designs that are the horizontal systems, and there's many more designs that are the vertical systems. I can get the answer to that question. I just don't have the exact number of designs, first off, or number of installations that are vertical versus horizontal. Yeah. There are more vertical canister installations.
it seems like other than Humboldt Bay, most of them are open air storage in the United States, and most of those that are in bunkers or in some sort of underground storage are in Europe and other nations outside of the United States.
There's a few of the underground ones. As a matter of fact, San Onofre is going to be putting in an underground one as well. But you're right, they're not as the underground ones are not as prevalent. Yeah. You have to have, part of it is too, is you have to have the right ground conditions, groundwater conditions and all that for that to work, right?
Yeah.
You can't put those underground in an area where you get a high water table. So there's other considerations like that I didn't mention earlier that you need to.
Yeah, the above ground bunkers of concrete, that might solve
exactly,
that problem.
Right.
And then there's always, in various reports, questions among constituents about high burn-up fuel and the fact that with uprates that occurred in the last 10 years in numerous plants across the country, including here at Vermont Yankee, that there could be some concerns about the storage canisters and high burn-up fuel. Do you know anything about that?
Yes, as a matter of fact, that's why these MagnaStore, that's the name I couldn't think of earlier, the MagnaStore type systems that some of these companies have developed are designed to hold a higher burn-up fuel, which ultimately lead to higher decay heat initially as well. So they look at each type of fuel element that comes out of these reactors, and in order to go into these types of storage systems, they have to have a certain amount of radiation that's coming out. They have to have a certain amount of decay heat that's being emanated from the fuel element. One of the ways they sometimes can compensate for that is they make more space in each canister between the elements. So if for low burn-up fuel, you might be able to store, say, 67 elements in one can. For high burn-up fuel, they have 35 elements or 38 elements in a can, so that the heat load is less and everything equals out. There's more space to allow for the heat dissipation and things like that. So they engineer the internals of the canister and the shielding and so forth to account for the factors that the fuel will exhibit, depending on the amount of uranium, the amount of fission products and all that that's in the fuel.
Hey, you talked about cask movement, and basically you described the short little trip that the cask takes from inside the building to outside, and there to sit for many years. But at some point, that cask presumably is going to move to a central storage facility somewhere.
That's correct.
And so, can you talk about what kind of long-distance transportation considerations are built into these casks and how that would happen?
Absolutely. As a matter of fact, let me go back to this initial picture here. See this one here? See these little fat little things in the end? Those end effectors there. When these dry cask storage systems were first designed, they weren't necessarily designed with transportation in mind, the very early ones. They were only designed to be stored on the site. So some of the early designs will have to be repackaged for shipment, okay? But in the 90s, when they were relicensing newer systems, the NRC decided, look, if we're going to license a system, we want the canister to be transportable, because ultimately we're going to take possession of that. So all of the systems now that are being used and being built are transportable canisters. So what will ultimately happen is the canister will come out of the shield, whether it's the horizontal shield or the underground or the above ground cylinder type shield. It will be put into a transfer or transportable shield, and it'll probably have those end effectors on it, like you saw, because those end effectors are there for major impacts, like train impacts and things like that. They will be loaded onto a transport vehicle, and probably ultimately a train or something like that, and then shipped off to New Mexico or wherever we decide we're going to have our long-term storage facility, if we ever build one. There are companies right now that are exploring national ISFACs, a national ISFAC, which is basically one large facility, whoops, like one of these that can hold all of the fuel from all of the nuclear installations in the country. There's pros and cons to that. You know, you get all the fuel in one location and nobody wants it in their backyard, so, you know, it's going to be a challenge to get something like that licensed. The good thing about it is that you eliminate 100 facilities and you have only one to concentrate on, right? One facility to have security around, one facility to protect versus 100 facilities to protect. So it remains to be seen whether we'll license a national storage facility or not, but that is under consideration, and there are many commercial companies that are in discussions with the NRC now and capital venturists and things like that to try to come up with the funding for that solution. So, that.
Thank you, Jay. This is helpful. You said that obviously there aren't 1 in 300-year studies happening yet. It's only been closing in on 20, 30 years. But is the NRC planning some long-term studies? I mean, admittedly, generations far beyond us, but is that in the playbook, if you will, for the NRC?
Well, they are for the 300. They are doing that 300-year study. As I mentioned earlier, that's actually, right, actually go on their website and you can see that. They have, you know, they discuss the fact that they're undergoing studies right now to look at a 300-year longer term solution. But
you said that was computer models, right?
Well, I mean, you're never going to be able to do a lot. When I said that, I meant you can't, until 300 years goes by, you can't do a real test on these things, right?
But there's certainly,
Yeah.
well, but I mean, there's certainly ways to preserve data for 200 and 300 years. And I mean, is that in the NRC's plan, is to figure out how to maintain that data long term so that the, 5 generations past the current NRC population are looking at this? And
I'm not
my hope for the
I'm not
subsequent
privy
generation.
to all of the details of the plan. I would assume that the plan has a process to make sure that the data and the history of the fuel and the chain of custody of that is all stored. I mean, I know that was the plan for Yucca Mountain, right? That was the ultimate plan for the repository, to have a chain of custody for every fuel element that goes into that facility. So, yeah.
We're way behind, but we'll let Jim do one, and then I'm going to take, I know, that's why we're going to let him ask, but then I'm going to throw myself on the mercy of the public too, but we'll let Jim go.
Jay, I understand the differences in the canisters according to the fuel and so on, as you explained it. Is there a difference in a model that would be a more expensive model as opposed to a cheaper model, all other things being considered?
Safety difference, you mean, or a?
I mean, let's say that there is a model that could be used at a plant that fits all the requirements. But is there 2 models? Is there a cheaper model and a more expensive model? In other words, can a plant go cheaper or more expensive?
Yes, because if you go out to bid and there's 2 systems out there that can hold your type of fuel, I guarantee the prices aren't going to be equal, right? You're going to get 2 different prices, and that will be a consideration for the site, right? And price depends on a variety of different things, what the construction capabilities need to be. If I'll give you a great example. These types of structures here need a different base than the pad structures or the underground structures. So depending on your site, the type of soil you have, the type of compaction you have, one or more sites might be more or less expensive just because of the preparation of the land. And I've seen that, right? Sites have chosen a site because we don't need to meet the same safety standards. We don't need to dig out as much soil and put in as much backfill, etc. So there's a lot of things like that that drive the cost, and also the economics of the companies that are bidding. Sometimes companies are going through a slow period of time. They'll lower their prices to get the job and things like that. So, yeah, there is going to be a difference in cost. Typically, it's not huge. These systems usually cost in the 80, 90 to 100 million to almost 200 million, depending on how much fuel you have. And, the difference in the costs might be a few million, so.
Jay, thank you very, very much. Yeah, we can clap. We talked about this for almost an hour now, and I know the public probably has comments, but I am wondering if we could move on to the next topic. And if you sign up over on that sheet over there, you're going to get an email from me with an email address that we will take your comments and your questions and share them with the panel. Nancy looks concerned. Do you have I can take one or two, but we have the next agenda item is rather large, so we want to make sure we have time for it. But I promise if you email me, I will share everything you share. Does one person want to go? Here, come up to the microphone so we can all hear.
I just feel like there were a number of people that had a number of questions, and I feel like maybe one or two.
Well, who wants to? We can take one or two questions. Okay. And if you can, and I don't mean to cut people off, but I want to keep it as short as possible so we can move on, because the next topic is a rather large one too.
This wasn't a setup. I'm glad she did that, but maybe someone at this table can answer for me. The thickness of the canister you said was 4 inches thick or 6 inches thick.
It ranges, I believe, from 3, a little under 5 inches, depending on the type of fuel, type of canister.
And with what we have here at Vermont Yankee with the high storm 100s, isn't the best I can find, looking at Holtec information, is that the actual inner canister is 1/2 to 5/8 of an inch thick. There's thick steel on the outside. Is that?
I don't know. We can look that up.
Okay.
Well, I'm sorry if I when I talked about the inner can, I meant the metal can, not the shield. Anyway.
Yeah, I'm talking the inner can that the fuel is in is 1/2 to 5/8 of an inch thick. I think everything else I'll be able to send in. Thanks.
We have one more, if you could, and if you could keep it short, that would be really helpful.
Very quick update to what you said. This month's issue of Nuclear News from the American Nuclear Society, there are some people who want a national facility in their backyard. In Andrews County, Texas, they already operate a facility that's licensed for all types of waste, high and low level, and they intend to apply for a license to the NRC for this national site sometime within the next year at the latest.
I'm just going to reiterate that if you put your email address on that piece of paper there, you will get an email from me, and then you can email me back with all your comments and questions, and we will pass them on. And if you have a question, I will do my best to get back to you with hopefully a correct answer. What we want to do right now is move on, because the state, and I don't know if all 3 members, or I don't know if Pat, so that's looking, three representatives from the state here are going to talk about what their department or agency, the role that they play, how they work together. So however you folks want to do it.
Thanks, Kate. We're going to do it in the following order. I'll go first, and then Chris, and then Bill. Bill, and then Chris, sorry. So I'll talk about what the Department of Environmental Conservation, which is a department within the Agency of Natural Resources, does in general. I'll be brief in case, so we want to leave time for discussion and conversation about this. I'll say at the outset that we have, since at least 6 months or so, I can't remember when we exactly started, maybe it's been longer, the 3 agencies and the Agency of Commerce and Community Development and the Department of Emergency Management and Homeland Security have been meeting at least monthly to kind of sit down and go over, share information, and kind of talk about what the issues are, and try to sort out how we're each proceeding. And
And there's also been ad hoc work groups, in particular, as you'll see from some of the way that jurisdiction or authority is broken out between the Department of Health and the Department of Environmental Conservation, there's a lot of overlap and interests. And so we've spent a lot of time working with Dr. Irwin to make sure that we can tap into the work that his department is doing, and plus his great knowledge and expertise in the area of nuclear power. So in general, what our department's focus is on the non-radiological contamination that may be at the site. This is, as I think I've described in the past, it's an industrial facility that was built kind of right about, in advance of and slightly preceding most of the major federal environmental laws in the United States. And so like a lot of those facilities, it has, there were a set of practices and things that, may have led to spills or contamination or use of materials that contain PCBs or, lead in paint and those kinds of things. So there's just kind of a standard set of industrial contaminants that may be at a site, are very likely at this site. And so our work in our department is to largely oversee and manage that, both the risks of contamination in soil or risk to groundwater. We also have a role in, to the extent that there's disturbances of soil, large amounts of areas and some of the construction activities that may occur, that we have stormwater provisions that we implement. There's also a wastewater treatment facility at the plant that now, is now running at a much smaller level than it used to, but it's still operating, and we permit that any of their wastewater treatment plant discharges. So that's kind of in a very broad sense the major thing. I guess I should also mention, to the extent that there's a reference earlier to underground storage tanks, so to the extent that there's petroleum storage at the facility, then that's an area where we have a regulatory role, both in terms of kind of any removals, dealing with contaminants and the like. One of the ways, one interesting kind of regulatory jurisdictional issue to understand about our authority is that in the context of what are called hazardous wastes, which are defined under federal and state law, very specifically to include a certain set of chemicals based on their characteristics or based on whether they're included on a list that EPA has developed. We regulate those under both our state law as well as a federal law called the Resource Conservation and Recovery Act. And we implement the Resource Conservation and Recovery Act authorities with the supervision and oversight of the U.S. Environmental Protection Agency. So we have, as we've been evaluating and sorting through some of the regulatory issues at this particular site, we've been consulting with and talking with EPA to make sure that we're acting consistently with that federal law. I've already mentioned some of the ways in which we're coordinating our work. So let me just jump into, there was one of the questions we thought might be relevant for folks to know about is kind of what are the different filings that we've been engaged in to date. We've worked collaboratively with the other departments on the comments on the site assessment report, on the post-shutdown, the PSDAR. Save myself the post-shutdown decommissioning activities. Thank you. And those are kind of the main things we've done. There was, in the presentation earlier by Entergy, there was a reference to a request for information that we submitted to Entergy that we're in conversations about. There's been a recent discussion between the kind of the technical compliance staff at Entergy and some of my technical staff, and so I think we're getting kind of into more of a alignment in terms of expectations going forward about how we will be implementing our authority. And then the last question that we tried to ask for each of our departments was kind of where are we in terms of our capacity and resources to provide the level of oversight. We're challenged at the moment to what we've done to kind of manage this. So we've taken some of our more senior experts and scientists that work on hazardous waste contamination and pulled them off of other projects to work on this, which has been a perfectly fine interim solution, but it's not going to be sustainable for us in the long term. We have other clients, customers, cleanup sites, industrial facilities that need permitting approvals and oversight and the like. So we're in the process of trying to figure out what else we need to kind of backfill for that and how we're going to pay for it, and anticipate having some more conversations internally within state government and with Entergy to sort that out. So I think that's my summary. I'll turn it over to you, Bill.
I know this one works. So the health department has a long history of evaluating the effects of having a nuclear power facility in Vermont since before they actually had initial criticality. There were cooperative efforts between EPA and the health department and others to get a sense of what the conditions of Vermont were before they started up and then after startup. And it was actually a lot of important things that changed with the operation of the plant because of cooperation of various parties, federal, state, and frankly, with the owners and operators of Vermont Yankee. For example, there was a shield wall that was put up on the west side of the turbines to reduce the radiation levels at the school. Radiation measures were taken and it was determined that that kind of effort could reduce doses at the school significantly, and very quickly after startup that was put in. And then dosimeters were placed all the way around the site and at different locations in Vernon and Brattleboro and the other towns in the Windham County area to measure radiation levels. Those close to the plant were designed to see what the plant was adding to the environment and public exposure, and those that were far away from the plant in other towns in Windham County were used as background. And what we measured outside of Vernon was subtracted from what was measured around the plant boundary. And we had a companion radiological environmental monitoring program that took samples from the water, soil, sediments, and air. And we've published that data since 1972. And it started out in paper that was put in libraries here and in Montpelier. And over the last 10 years that I've been here, we've published it electronically. You can find all of those, and you can still look at the reports from the 70s, 80s, 90s. You can see from our measurements of the environment the effects that occurred with Chernobyl in 1986, as well as even some results from Fukushima in 2011. The companion to that process of environmental surveillance has been an emergency response program that worked with the NRC, FEMA, the Vermont Emergency Management Agency, as it was at the time, now the Division of Emergency Management Homeland Security, to meet the off-site response organization requirements for radiological emergencies at the plant. And for decades, the Department of Health has worked to train people across the state to develop instruments and procedures and plans and techniques to measure releases as they would occur in the air, and then try to provide the state with guidance as to what to do for protective actions for members of the public. And the mechanism for funding all of that over these 42 years has been through emergency management. And this effort is somewhat mysterious in its outset, but the way it has been practiced in the last 10 years is fairly clear. The budgets of the states, agencies, and towns prepare a budget based on what they think they would spend in the coming year for environmental surveillance and radiological emergency preparedness. And that would be accumulated by Emergency Management, Homeland Security as one budget, and that would be submitted to the legislature, and the legislature would negotiate with Entergy a final figure for the towns and the agencies. And then as towns and agencies submitted invoices for actual expenditures, those actual expenditure invoices were reimbursed. And this has been the method by which the health department has conducted its work for a very, very long time. Where we stand today is that we believe that the environmental surveillance that we've been doing needs to continue until the site is released by the NRC for unrestricted use by the termination of its license. And that's based on the fact that while it is in safe store, though it's no longer a boiling pot of water, it is still a collection of components that hold water. Some of that water has leaked out, and that water contains radioactivity. And until the final status survey is conducted to prove that the site meets the release criteria for unrestricted use, an environmental surveillance program by the state, a third party, is required to verify for the state that the non-operations of the plant no longer affect health and safety of the public or the environment. Two, that the radiological emergency preparedness needs to continue at essentially the same level as it is today until spent fuel is put into dry casks, which is currently planned for 2020. After that date, there would be a much lesser need for off-site response organizations. However, we believe that releases that could occur underground in groundwater, as well as fires that could release radioactivity that's stored on site in the smoke, or other industrial accidents or hostile action-based incidents that lead to releases of radioactivity that remains in storage there until dismantling and decontamination, requires more than law enforcement, emergency medical services, and fire departments. It requires the kinds of expertise that have been developed over the last 40-some years. And we, unfortunately, with the current funding mechanism, i.e. depending on negotiated funding between the legislature and Entergy, the current conditions appear to be that after this fiscal year 16 that starts July 1, 2015, there would be no funding for anything that we do relative to Vermont Yankee. And so any reports that we've published for 42 years, any findings that we've made in our laboratories or published in our documents, any work that we do for radiological emergency preparedness for Vermont Yankee would no longer be funded, and without that funding, it could not exist. So we are concerned, clearly, that the state would not be served by independent environmental surveillance, nor with expertise that could be of value would there be a groundwater contaminating release or an air release in some sort.
Okay, thanks, Bill and David. I'm going to skip to the how are we coordinating this effort a little more first, and I'll come back to what the department does. But I do want to emphasize that, as David said, we have been meeting regularly. There's really outstanding coordination between ANR, the Agency of Commerce Community Development, Department of Emergency Management and Homeland Security, and the Department of Health, the Agency of Human Services. Also in the Attorney General's office, and we have a good team working on this and kind of trying to work through the issues as we go forward. So I'm really pleased with that. In terms of the Public Service Department, we are the lead role in Vermont Yankee decommissioning because it was an electric generating plant subject to Public Service Board oversight and therefore Public Service Department as a public advocate interests. Generally, we assess information regarding the ongoing activities at VY. As you heard from Tony, he's an employee of mine, the state nuclear engineer. I am also the designated state nuclear liaison with the NRC. So we have direct contact with the Nuclear Regulatory Commission on a fairly regular basis and provide information. We get information and we receive information and then share that with the other agencies, and now also with Endicap when it comes in. We also are really actively involved along with the other agencies in the governor's office in negotiating with Entergy the agreement that we're all operating under, and will play a role before the Public Service Board in the review of the second ISFC pad that needs to go in to accommodate the remaining dry cask storage needs. So our overall role is to assure that as a public advocate and public service entity that we're representing public concerns regarding this decommissioning process, and we make sure that they're addressed. Getting information from the NRC and Entergy, providing comments to the NRC and Entergy on these activities, and obviously assure that on-site spent nuclear material is permitted through the Public Service Board process to stay on site and until next week when the federal government will be picking it up. Now, in terms of filings and things that are going on, there is a lot going on. And one of the things I would ask of Entergy, and we'll talk to them about it, is it would be real helpful for us to have a list of, well, let me back up and say, the Nuclear Regulatory Commission only has rules regarding operating nuclear power plants. They actually don't have any set standards and requirements for how to not operate a nuclear power plant. And so you'll hear a lot about exemption requests and license amendment requests. And those are not, in general, the vast majority of those are not asking to get out of doing something. They are things that are no longer applicable to this plant because it is no longer operating, and yet they are called exemptions. With that said, there's a whole list of them, and they are being filed, and I would like to better coordinate with Entergy on understanding what to anticipate, because we've gotten a handful of them already since the plant has shut down. And we've had to be responsive to those and are being responsive to those. And right now we have filings with the NRC regarding the emergency planning zone and Vermont Yankees site fence line. We have comments on the oversight of the decommissioning trust fund and expenditures from there. And we have comments on the data feed for emergency response and the system that was in place during the operating plant and a replacement for that. So, that's 3 examples. There are others that Entergy has applied for that we're reviewing and responding to. Some of them require public comment or have a public comment opportunity, and some don't. Some are exemptions and some are license amendment requests. Sometimes there are exemptions that are requested that, if granted, automatically yield the result of a license amendment request. So we pay attention to all that, and we'll continue to engage on those processes as needed. And then lastly, in terms of the resources, I think we're in a little better position than the other agencies, but we too were funded through the electric generation tax that used to come, and without generation there is no generation tax. Well, there is still a generation tax, just the payment times 0 is 0. So right now I am supporting this committee, Tony's work, and several of my staff are being supported through the gross receipts tax on electrical generation from others. So that's kind of where we are at the moment. That's how we work together. Those are the issues that we're paying attention to and the authorities that we have that we summarized here. And I think we're all 3 are happy to answer any questions you have. And we got you caught up within 10 minutes.
I'm going to take up that 10 minutes for you, Chris. No, I'm Pat Moulton. I'm the Secretary of the Agency of Commerce and Community Development, and our agency has actually no physical role as it relates to the decommissioning, no regulatory role, et cetera. But our agency is responsible and helps work with communities on the economic recovery of the closing of the plant. We have a community planning and revitalization division. We have an economic development department that will help communities, and we are administering the Windham County Economic Development Program, which is the funding Entergy has provided through the agreement to assist with long-term economic recovery here in Windham County. So that's really our role. I am sitting in meetings with the Department of Health, Agency of Natural Resources, and Public Service Department on a regular basis to keep myself and our agency informed about what's happening. But we don't regulate or have a whole lot to say about what happens on the site. It's more about what happens outside of the site.
That's good. I'll ask a question. And I don't know if this is more towards the Health Department and the Department of Environmental Conservation, but I think there are things that you would like to do, but there are things that you can do. You know, like somebody says, yes, you can do this. So I don't know, my question to you would be, what is it that you are allowed to do because some higher authority, whether it's the Department of Energy or it's the NRC, says that that's your oversight capacity? Do you know what I'm saying? Oh, great. Because I think, Bill, you were talking about things that you'd like to continue to do.
Yeah. So the first thing is that NRC regulations do not provide any mechanism to support what the Department of Health in Vermont does. And those are really the only rules that Entergy has to follow. The good news is that for the history of the plant, there have actually been agreements among the parties to abide by the rules and to support the work that we've done. And absent any other commitments than those made in these kinds of agreements, there really is no other that says you can do this. We would like to do what I described previously, but it takes money to do that. Unfortunately, there's no rule that says that money has to be provided in order to do that.
One question before you move it over. So are you saying basically the health department's role, when will it end in relation to the plant?
Well, as was presented in a meeting a few months ago by Chris Wamser, they have pledged to continue funding the Radiological Emergency Preparedness Fund through April 16. And so that would put us through next April. So it's about a year from now. All the funding for the people at the health department to do everything for Vermont Yankee will cease.
In terms of what kind of our ultimate and shared goal is, from Entergy to the health department to our department to EPA, and I suspect the broader public, is we just want to make sure that we have fully characterized all of the risks at the site, and that we know that they're all managed in a way that will minimize the risk to human health and the environment. And that means environment meaning, the Connecticut River, and meaning, wildlife, the ecological health of the area, and all of that. And so those are, kind of shared fundamental goals. And, one of the challenging parts of a cleanup that involves NRC involvement and the this kind of somewhat artificial distinction between radionuclide to radiological risks and risks from other kinds of contaminants, is that those things they're cumulative. There may be intersections and synergies between those risks. And so part of the challenge and complexity for us is to try to figure out how we exercise our authority in a way that doesn't run afoul of kind of principles of federal preemption, the concept that the states can't kind of override federal law. But at the same time, ensuring that we have developed our cleanup standards in a way that meet the kind of bottom line public health and public safety and environmental protections. So that's, that's our challenge and work going forward.
Like, when does your role end?
Well, it's such a, for a normal facility, it's in the context of a facility where there's material that may be left on site for many decades or beyond. As long as there is a state of Vermont and a Department of Environmental Conservation, that we will be involved because there will be risks to manage long-term at this facility unless and until all of the contaminants are removed. Or stabilized or managed in some way. And to the extent that there's any materials that are left on site, I think for both the health department and my department, we will want to have and will seek to have some monitoring and oversight. Well, whether it's groundwater contamination or the radiation risks that the health department want to keep track of and all that. So I don't plan on going away anytime soon. One other I think somewhat interesting issue for all of us has been as we are understanding of how the NRC decommissioning process works, it's, as I described at a previous meeting, somewhat different, where there's a lot of back-end review at the tail end of the decommissioning process, whereas typically with the kinds of work that we do, we require a closure plan up front. And so that's where we're in fact working right now with Entergy to kind of figure out how to navigate that.
Have the authority to continue. No one can give it to you or take it away. That's my basic question.
Right, we have an existing set of authorities under state law that are not preempted as they apply to the non-radiological risks at the site, and we also have authority that we have under federal law, the Resource Conservation Recovery Act law that I mentioned earlier.
While we're talking about breaker one then, okay. I just want to mention that we're largely resourced by the state through Pat's agency. The vast majority of our funding comes from the state. Only about, I think it's about this year, about 7% of our funding comes through town assessments. And the agency folks sitting around here are aware of our resource needs to actually serve our function as the host region for the plant and doing the work necessary to provide local input into this. And we're similarly struggling with the question. I think even up to the governor's office, I think there's recognition that it'd be good for the regional commission to have resources to work on this, but thus far they haven't manifested themselves because of a tough budget period. But I think this just underscores also a fundamental flaw in the federal regulatory process in that no matter what locale you are, you don't really have the means to really participate, especially in this stage of the game. I've spoken with public advocate staff on Chris's staff about even how they're engaging in the NRC process right now, and just the gates that you guys have to keep trying to get through just to get the filings done and reply. And so we're increasingly reliant upon the state agencies to carry the local interests. And then just as the states, I know Chris, you said this several times to the NRC, that we're dependent on the NRC to do their job to provide effective management and oversight. And I'm not crying poor. I just want, but since this is a panel, I just feel like we need to kind of explain our situation. This has been the case before the Public Service Board and everything else too. The only time we've had any kind of bill back authority was during the leak docket, but otherwise this is coming out of everything else that we have to support. So we're doing the best we can, and we'll keep on keeping on.
So I'm not sure if this is going to come out right, but I'll take a stab at it. I'm kind of confused as to the money aspects of this. It sounds as though what we're hearing is if the funds dry up from Entergy, then these departments can't really continue their missions. So I'm curious, when Fairpoint comes before the Public Service Board or Comcast, or a company is coming to the state for a permit for some sort of a hazardous waste operation, Is it also the expectation that those companies foot the entire bill for what the state deals with? And I'm not so much from a spill response, but just from the administrative duties that go on. And how does that differ from Entergy and why?
Right. So I'll answer that because I think from the Public Service Department standpoint and Public Service Board processes, I think that's exactly the right question to ask. We do, for anyone coming before the Public Service Board for a certificate of public good, we bill back to that company the costs of doing that process. If they are a generator and contributing to the gross receipts tax already, then we don't double bill them. We use that for our staffing, and we bill them for expertise, outside experts, or other work that might be needed. We also have the ability to bill back for ongoing interactions with a CPG holder, and that's fine. It's just recognize that to the extent that this is decommissioning related, and I'm not saying this, that I agree with this argument, but the argument is, well, then that should come from the Decommissioning Trust Fund, which means we do the work, we bill Entergy, and then they would seek to recover that from the Decommissioning Trust Fund. We are sensitive to the fact that A, we need to get our work done, B, we need to be very efficient, and C, we need to grow that fund as soon as possible and not be withdrawing money unnecessarily from it. Money does need to come from it occasionally. We would argue that the Nuclear Decommissioning Trust Fund was established for radiological decommissioning purposes first, before the other purposes. And I know there's disagreement about that. But the point is that the work that these guys are doing is not radiological decommissioning. So A&R has the ability to bill back through our process. Department of Health, if we need their services, we can do it on their behalf, but they don't have the direct ability to do that. And the type of work we're talking about here is non-radiological work, at least in the NRC context. That's not our purview. And so where that money comes from is the question. But, you know, most of us get a certain amount of money from either the federal programs or the state programs, or through fees and for permitting and process, which was the nature of your question. And usually the latter, that last part, is paid for by the entity that's seeking permission to do something.
I don't want to put words in anybody's mouth, but am I hearing that Entergy's, the bill back practices for Entergy are being handled the same in the state as other major utilities and other large companies?
Yes, they are.
I was going to say, we're treating Entergy the way we would treat any other nuclear power plant that was closing in the state of Vermont. But I do think that one thing to know is that we, just as a general, kind of build on what Chris was saying, that in general, you know, any company or industry that we regulate, we typically are paying for the cost of our regulatory oversight through one of three ways: regulatory fees, general fund dollars from the state, you know, general funds that are, you know, paid by taxes, and or federal grants that we get from EPA. Those are kind of the three major ways that we pay for things. And in the current instance, under the framework we've had, I kind of weren't prepared for this transition, and so didn't have in place a fee system, or, you know, to capture the costs that we would normally share with the regulatory entity. So we are looking to the bill back authority, which is kind of a gap filling authority that we do use when this happens, which happens from time to time. So we are treating Entergy in the same way, but it's sufficiently complex and new to us that we're trying to sort through it carefully to make sure that we do it in a way that's thoughtful, because we don't we've been having to, our understanding of what level of staff resources we would need has evolved, frankly, quite a bit over just the past few months.
Maybe I could just also add, there's another complexity in this, which is time. Dr. Irwin mentioned, that they've had 42 years of experience in doing this because there's been 42 years of an operating power plant. But as we go into these next stages and kind of answer Kate's question a little bit, as far as I'm concerned for my department, pretty much when the spent fuel is out of the pool and into dry cask, my department's involvement really diminishes considerably. And these guys really take over in terms of, until the site is available for any use and cleaned up to whatever standards people have. But in between there, there's a ton of there's times when we need to all be fully staffed and engaged and able to respond, and then there'll be periods of time for years where not much is happening, and then there'll be another big slug of things. And I know you all realize how nimble the state is, but this start-stop thing is probably going to be a challenge for us in terms of being able to be ready and able to respond at the right times and not be overbuilt for the times when we're not needed.
That's a good lead-in. Commissioner Mears, I had a question. You went through your kind of overview of your department's role, and when I think about the backdrop that Vermont Yankee has operated for a number of years, and we have had a robust hazardous waste management program on site, and we're cognizant of state and federal law. And we've had oversight from your group through things like stormwater and septic and those other things you talked about. And knowing that the limited spate of activity that we have right now, the small scope of buildings that were taken down that will end pretty darn soon, in the next month or so for the most part. In your overview, you talked about the need for expanding your staff. And I don't quite really understand the basis for that when I think, we had a program, we were operating a facility, we have a short period of activity right now that's about to come to a close realistically, and we'll continue to have a robust hazardous waste management program going forward and comply with state laws. And the further out planning activities related to site closure and those types of things, I think we all would acknowledge under Safe Store, we're talking many, many years down the line. So I don't quite understand, what is it you see coming that is going to require you to, I think you made a reference to backfilling positions right now. And I just don't see the workload there.
I appreciate the question, and part of there's a certain level of uncertainty to what we're projecting in terms of what our needs are going to be. So, I think it's a fair question and one we're thinking about ourselves. But to put it in a different context, it's not as though we're just kind of continuing on in the same vein as we've been for the last 40 years. We're closing out a site that was built many decades ago. And there have been a set of activities over at the site that none of the people on my current staff were there around to see. And we don't know what's buried under some of the, we know we have some records, for instance, of oil spills, for instance, that we couldn't completely fully remediate because there were buildings on top of that spot. So we know when you pull up the foundation of the building, you're going to find some more materials. So we're just trying to pour through a lot of historical information to kind of figure out what is the extent of the contamination or potential contamination. And that's just a lot of work all of a sudden that we've been called upon to do really in a fairly short amount of time. So I've had to shift staff to work on that set of issues. Staff who were working on a whole, they had full-time jobs before they were doing this. So all of that work is now kind of piling up. So that's what we're trying to figure out how to manage through. And you manage staff and programs. Our challenge is we don't want to just add staff that, as Chris describes, then we get through this burst of work and it turns out there really isn't much for them to do. At the same time, we know at the moment we're feeling overwhelmed and we're trying to figure out
and project what we need. We may need to bring in temporary staff. We may want to hire consultants to give us some expert advice. So it's a work in progress. But it isn't just simply kind of just business as usual. It's a pretty substantial new effort for us.
On the panel, do you have any more questions? Does anyone in the public want to either ask a question or comment on what you just heard about the state's role? Leslie looks like she does. Can you come over here so we can get it?
No, I appreciate the explanation. It was very clear. I understood everything. But while Jay is still here, there were some questions I had for him. Can I ask him now?
Sure.
Great. Okay. A lot of the folks on the panel asked the questions I was going to ask, but I do have some questions about high burn-up fuel and about storing high burn-up fuel. And you had mentioned the, what was it? I want to say Magnavox, but no. It's MagnaStore canisters with high burn-up fuel. At other sites, are they storing high burn-up fuel in anything other than MagnaStore canisters?
Can you know? Okay. I'm not an expert on the fuel designs themselves, the canister designs. I don't have that exact answer to that question. I know the MagnaStore type of design is designed for fuel less than 5 years. It's got some high burn-up capabilities. I could certainly get that information for you. I can tell you exactly the types of systems and the types of fuel burn-up rates that will go into the types of systems, but I don't have that information, unfortunately, on the top of my head. And let me also point out, too, that the gentleman pointed out the canister thickness. I did a little research while I was listening to you talk. I had looked, to simplify my presentation, I looked up some average thicknesses of canisters. He's exactly right. There are different characteristics of different canisters that have multiple layers or overpacks, where the inner canister itself can be less than 1 inch thick, 5/8 inches, the thinnest I saw, but I could also do some research and get you the exact values on that. But if you look at the average thickness of canisters, when you look at the end plates, the side, some of the end plates are up to 9 inches thick, depending on how they're designed, vertical or horizontal. And they're quite complicated when you look at the inner and the outer pack. So I apologize if there was some confusion before when I gave you an average range, but you know, depending on the installations, the thickness of the metal on the inside of the shield, the overpacks for transportation that are required. There are some systems designed with the inner canister that can be thinner as long as when it's transported, it's put into a certain thickness overpack for the safety considerations. So.
The other question I had was somewhat similar to Pat's question about if we had the first canisters being certified in 1986. And so that gives us till about 2026.
Well, you don't have the first ones, the ones that Surrey
No,
have.
I'm just talking about how much experience we have with canisters. So everything beyond that is based on computer modeling.
That's true.
Right. And what we want to do here in Vermont is obviously get the best protection that we can for our, you know, the radioactive waste that's going to be going in there. So since that time, have they looked at the effect of the type of fuel and how that has changed over time when they've designed these new canisters? And also, have they looked at the fact that we've been overpacking the fuel pools, and have they changed perhaps the process by which we're moving the fuel into the canisters? Do you think they've made great strides in that? Do you think that's been a robust process?
Yeah, let me break it down a little bit and answer each part as I think you've asked it. You're right. We've only had spent fuel canisters really in operation since 1986. But, you know, it's like when you develop any type of a new invention, you develop it with models and things that you think are going to be safe, and you might tweak it along the years if you find out that, or develop a new system and completely redesign it if you find out that it's faulty. But I will say one thing about the metallurgy aspects of nuclear fuel. Nuclear power plants have been in operation since the 50s, all over the world, okay? We didn't really start going really big and heavy into commercial plants until the early 60s, but England's had them since the mid-50s. And we've done, a lot of the studies on the metal canisters have come from the studies on the reactor vessels themselves. What is radiation at very high temperatures due to certain types of stainless steel, certain types of carbon steel. So there's a lot of data that we have that goes back well more than 1986 that looks at the degradation of metal from radiation. So although we haven't studied spent fuel canisters since 1986, we do have practical studies under much more, I would say, corrosive and high temperature conditions that we used to extrapolate the safety of canisters. So, you know, that's all taken into consideration when they develop the designs for these. You asked a question about the movement from fuel and fuel pools. And
well, we
I
have
understand exactly what you're.
Since we haven't found a storage solution for the waste, our fuel pools have become overpacked. So I'm wondering if you know if the process for removing the fuel from the fuel pools and putting them into dry cask storage has changed over time to keep up with that overpack.
Well, I think the answer to that question would be yes, because what we've done to our fuel pools over the last 30 years or so is we've redesigned them to hold more fuel. And there's been a number of different things that we've done. And when I say we,
but ours
I
is
mean
the same as
the US,
it was
the
in
industry.
1972.
I can't speak to the Vermont Yankee fuel pool, but I can tell you that many other facilities in the United States have designed racks that absorb more neutrons so they can put the fuel closer together and maintain the same safety considerations. Some plants that have had very deep fuel pools have done double storage, right? So when they go to load this into dry cask storage, they have to consider the new types of arrangements in the fuel pool so that they can safely load the fuel, take the fuel out of the racks, move it over to a storage location and into the canister. And each fuel pool is designed a little bit differently. There's different, they all have some empty space where they can store the canister for loading. They're designed for that because they were designed to load the fuel out of, and originally to send to the DOE for reprocessing.
And we've moved it into spent fuel casks since then also.
Exactly.
Okay, thank you very much.
You're welcome.
We have time for one more question or comment.
Hi, thank you. I'm Sally Shaw. I live in Gill, Massachusetts, in the former EPZ. I have a couple questions for Mr. Tarzia. One is, what's a giga?
More than a bega, it's more than a billion and less than a femto. Now a giga is, let's see, giga would be 10 to the 12th? Yeah, 10 to the 12th.
Okay.
I have to think now. So
10 to the 12th.
So
Okay.
you got a gigabyte would be like how many?
10 with 12 zeros after it?
Yes.
Okay, so if 1 becquerel is 1 radioactive decay and 1 curie is 40 million radioactive decays, that's 40 with 6 zeros after it. A gigabecquerel would be what? How many curies?
I can get my calculator out and figure out that. Let's see. Yeah. 2. That's right. So that's correct. So it would be approximately 2.
A gigabecquerel Is 2
1
curies?
gigabecquerel would be around 2 curies, right? Because that would be 2.2 times 10 to the 12th. Well, it depends on what you're talking about, disintegration. Yeah, gigabecquerel is 1 disintegration per second, right?
No, I thought a becquerel was 1 disintegration.
A becquerel, I mean, is 1 disintegration per second. And a curie is 3.7 times 10 to the 10th disintegrations per minute, right? Disintegration per second.
So it's approximately 40 million.
40 million, right.
Yeah.
2 point, I have to do the math, but.
Okay. The point being, back to your graph, I carefully without a ruler, but as quickly as I could, put the lines in on your graph, and it looks like after 100 years, the total radiation is 10 to the 6 gigabecquerels, and we would multiply that by 10 to the 12th, right, to get...
Curies? No. No. A gigabecquerel...
Well, if a becquerel is 10 to the 12th, then 10 to the 6 gigabecquerels is 10 to the 6 times 12 becquerels.
Can I ask a question on...
Which is going to be a lot of curies
What's
after 100 years.
It's a lot of curies.
The point being that the warm and fuzzy graph that says it's mostly going to be gone in 100 years
No, I did not say mostly gone. I said 1% of what it is originally. All right?
Yeah.
I did not imply mostly. There's still a lot of activity left after 100 years.
There's a lot of activity.
Absolutely.
That's the point.
I'm not sure the math that we
That's the
talked
point,
about
but I
is
don't
correct,
think
but-
anybody knew what, I mean, we're used to talking about becquerels,
No,
we're used to talking about curies, we're not really used to talking about
Let me explain
gigabecquerels.
what the point I was trying to get there. We are designing canisters today to hold the fuel when they come out of a fresh reactor, okay? And we're doing studies to look at the longevity of them as the fuel is today, all right? My only point with that discussion was some people don't realize that fuel decays away over time. Believe me, and you guys are a very bright group of people, and I'm sure you understand this. But what a lot of people don't realize is that the significance of the fuel in 100 years will be, from a radioactivity perspective, will be 1% of what it is today. Now, does that mean we need 1% of the safety of the fuel canisters? Absolutely not. But the point is, as time goes on, and 100 years is a long time, and 4,000 years is even longer, what we design for the fuel is going to be less significant from a safety perspective than it needs to be today. So if we're designing a system or multiple systems to protect the fuel up to 1,000 years, the type of system that you need 500 years from now might not need to be what we need today. And that was really my point on that.
Right, but the point, that's a little bit like the waste confidence rule, don't you think, where we don't really know what the solution is, but someone will
We
figure
don't
it
even
out?
know if the United States is going to be a country in 500 years.
Well, I think this is
Right?
a pretty shame, well, I won't go into it.
Hey, Sally?
Number two,
Can you
I'm
make
sorry.
Can you make it really short? 'Cause
I will try, I will
Okay.
try. I've been sitting here for 3
I
hours.
know.
We had a long industry-related presentation, and you're cutting off the public comment, which I don't think is appropriate.
Well, we're trying to be fair and move the meeting along, but if you can make it short, it'd be great.
Question number 2, what kind of casks were used at Fukushima, the ones that survived the earthquake and the explosions? That being the same type of reactor as Vermont Yankee, presumably using the same type of fuel except for reactor 3, which had MOX fuel. Do you know what kind of
I don't know specifically, but looking at...
Okay, I don't want to take up time. I just want to encourage the committee to look into that. Number 3, your comment about leaks in Holtec casks. You said something like there have been no known leaks in any type of cask since dry casks were invented, and I would encourage the committee again to question that statement and try to independently verify it. I remember during the dry cask docket before the Public Service Board that we found citations for Holtec casks that actually did leak after 10 years. I don't have that citation with me.
Yeah,
and I
you'd
can't
have to,
get internet
I have
in
never
this
seen
location.
that. The NRC
Well, then I think you should be very careful about making excuse me, I think you should be very careful about making statements to public officials that are expressed with certainty if it's simply a matter of, I haven't heard of anything. Okay. Fourth question. you made a statement about the heat coming off the dry cask being similar to the heating system in your house. I can go up and put my hands on our boiler down in the cellar, not feel any heat. Could you go up to a fully loaded dry cask and put your arms around it?
Yeah, well, yes, you could from a heat perspective, absolutely.
And from a radiation perspective?
No.
Okay, well, isn't that a somewhat deceptive analogy then?
No,
And
because I was talking specifically about decay heat.
All right, but decay heat to some people makes it sound like heat, and we're actually talking about...
That's what it is, it's heat.
Yeah, but we're actually talking about, with dry cast, something much more important than just the
David will
the
answer that
residual heat.
question.
As somebody who works next to the casks, I can answer that question.
How close can you get to them?
I hug them.
Oh, you do hug them?
Yes, I went out.
Oh, isn't that sweet?
Yeah, so I went out and cleared snow, and it was 9 degrees below zero at 3 o'clock in the morning, and if I
Yeah.
looked up, I could barely see a little bit of steam coming up off the
What
top.
did your little badge say?
The dose readings on our casks are so low, I have to use a special meter that reads in micro rem in order to get any kind of a reading.
And so how long could you hug them?
Forever. Micro rem. So everybody knows that's 1,000th of a millirem. I can't use the regular meters that we use. We have to have a special meter because the dose is so low.
Let's clarify something here, though.
That's pretty impressive. I'm happy to hear
That's the outside of the shield cask. When I was talking about the actual physical heat, if it wasn't for the radiation, you could go up and touch the canister.
But it
the inner
is for the
canister.
radiation, and that's what we're all here
That's
to
right,
be
but we were
and
talking
all
early, when I
concerned
made
about.
that reference, I'm not trying to be disrespectful, please. I just wanted to explain that when we were talking about that, we were talking about the cast design in the airflow to remove the amount of heat that actually gets generated, okay?
I understand
The
that.
radiation is a different situation, and that's why we put the thick concrete or inner metal and outer metal canisters around them to protect people from the concrete, and that's what Dave was talking about.
Okay, and is it the Holtec High Storm 100 cast that Vermont Yankee's proposing to use?
That's what they're currently using now, is the high storm.
That's what they're currently using. So I'm sure that the specs for those are online, and we can check your statements about how thick the inner metal
Yes, the inner
stainless
canister
steel
is, I believe, 5/8 thick with a...
I thought you said 2 to 4 inches.
Well, I just explained that I looked up average thicknesses of canisters, and some of these designs have multiple they have
Layers.
overpacks and metal liners within them, so...
Yeah.
I apologize for that confusion.
Thank you. And Jay, and Jay, thank you so much for coming over here from New Hampshire. I'm going to do a quick recap after Senator Kelly's wants to say a few words, and then we'll recap, and then we'll adjourn.
It's on? Yeah, okay. I just want to let the panel know that I am not going to be able to attend any future meetings, but Diane Becker, who is the Chief of Technology Hazards and New Hampshire Homeland Security and Emergency in New Hampshire, is going to be taking my place. I will be in contact with her as often as we are now, and will continue to be. I want to thank the panel so much for the invitation, for being able to be a part of these discussions. I'm learning a lot about Vermont in the process, which is great, great neighbor, and hope I can get over to a couple meetings, but my schedule is just almost making it impossible. And so in order to really represent New Hampshire and continue to receive the information and be a part of these discussions, I think it would be best if I stepped aside and Diane will be taking my place. So the governor of New Hampshire has sent a letter to Diane as my replacement and accepted the fact that I would need to step aside. So thank you again. Been wonderful meeting all of you. I hope I can continue to be a part of these discussions in some way. I do see the minutes. I know Tony's got it live whenever I need to do it. So great. And I'm sure we'll continue to speak with each other. But thank you. And thank you for all the work you're doing here, all of you. It's great work.
Thank you, Senator. I do want to just say that I hope we didn't scare you away. And thank you for your participation and for inviting Jay and getting him here. So we wish you well. And I noticed that it's a little, our Vermont legislators are not able to be here either. So I get it, particularly during the session. This is hard.
Thank you, Molly, and we look forward to seeing you, Diane. Before we go, we'll just recap. Oh yeah, Diane can wave. The next meeting is going to be May 28th. We don't know where yet, but we'll figure out the place. And then the meeting after that is June 25th. So does somebody want to make a motion to adjourn? I'm assuming we're all going to vote yes.